Woohoo! Welcome back! Today we're going to be working with 0.3 and stray rabbit hairs. And Sharktopus is here to help us as our, support carnivore. We're going to be reviewing how to work with exponents. And these in 0.3, this is going to be integers as exponents. So this is a good review for everyone. Hopefully this is something you remember from your algebra classes, but just in case, I wanted to go over it, make sure everybody's up to speed. So all we're going to be doing is, rather than going over all the theory, is I'm just going to dig right in and let's get started with the practice. So the very first is 3 with a little 2. Of course, the little 2 is the exponent. And the 3 is called the base. And this will become important later, so making sure you understand the vocabulary is important. And what does this mean? Well, this means to take a 3 and then multiply it by another 3. There are 2 of them, and the way we pronounce it is either 3 to the second power or 3 squared. And in order to figure this out, I've got 3 times 3, which is 9. A lot of folks probably have this already memorized. But if you don't, and, and if your brain is not, not everybody's brains do great with exponents, you can always pull out your handy dandy calculator. This one is the TI-36X Pro. You don't need to get one. Oh, there I am. Hello. And, but what I want to show you is on this particular calculator. Let me see if I can get this nice up and close without showing you too much of the ring light. Right there is the exponent key. So I'm going to go ahead and turn this on, clear it out. I would use 3, my exponent key, and squared. And you'll see that it's got that little kind of arrow top, rooftop. That is how you would use exponents if you're working with like a desktop or a laptop. That's the little character that's above the 6, and that would tell us to take a exponent as well. I'm going to hit enter, and woohoo! Quelle surprise! We've got 9. Yay! This is very exciting. Okay, shall we do some more? Okay, dum dum dum. B and C are included because they're the ones that folks find the most frustrating. And I agree, if you've never actually worked with order of operations, or if it's been a long time, this is a really tricksy concept. But let me show you the difference between these two. Notice that I've got a minus sign. This is actually a negative. It's not actually subtraction in this case. It's a little different, but it looks like a minus sign, and then 3, and then squared. And the way that we read this is that there's a single minus sign or opposite sign, and the 3 gets squared. So notice there's only one minus sign there, so the whole thing ends up being negative. Woohoo! So now how is this different? Well, this is a situation where we've got the parentheses, and they hold the minus and the 3 together. So the whole thing is -3, and that whole thing gets squared. So in other words, it looks like this. Now, since there are 2 minuses, oh my goodness, I don't have the Bat Brothers. They're still off on vacation, so I'll have to do it with my fingers. If you've got 2 minuses, it becomes a plus. Let me do that again. 2 minuses, it becomes a plus. So -3 times -3, +9. So the difference here is when you've got parentheses around the negative as well, it means that you square the entire -3. If you just have a minus out in front or a negative sign out in front, and then the 3 is squared, there are 2 3s, only 1 minus. So far, so good? Woohoo! Hopefully you're thinking, oh yeah, this is all coming back to me. If not, let me know. If this is not enough practice, if it's been a while, or it just never made sense to begin with, definitely talk to me. Send me a note, message me, email me, talk to tutors. We got lots of math tutors who would love to help. And we'll just sit down and help you practice, because this is going to be an important concept in this class. Okay, let's keep going. This is very exciting. This is not a concept that you could just figure out by yourself, unfortunately. And so, what? And my brain just went sideways. Sorry. And so what you need to do is you just need to know how to do this. 3 to the 0 is 1 by definition. Anything except for 0 to the 0 is 1. So if I have 0 to the 0th power is undefined. Anything else, like if I have 5 to the 0, that's 1. So only 0 to the 0 is undefined. Now, having said that, I'm then going to give you this problem. Negative 3 to the 0 equals, and you're going to say, oh, it's 1. And I'm going to say, no, it's negative 1. And everyone's going to go, what? And then I'm going to go, yeah. Why is that? Well, for the same reason in part B. So let's take a look. This is actually read as the opposite, and 3 to the 0 is kind of its own thing. That exponent is very nearsighted, like I am, cannot see the minus, does not affect the minus. So the minus is left out, and 3 to the 0, they party, the minus is hanging out, and then it becomes negative 1. So what if I want the minus to come to the party? If I want the minus to come to the party, just like in part C, if the minus needs to come to the party, I need to invite it, which means parentheses say, you guys are coming to the party together. So I've got negative 3 to the 0th power. That is 1. So these all seem really perhaps simple. They aren't easy. This is complicated stuff. If you are feeling rusty right now, if you're looking at this going, what the what? I don't even know what to do, then please reach out. Talk to a tutor, talk to me. We will just go over this, try to explain as best we can. Some of the reasoning behind why the 0th power ends up with a 1 can be a little bit elusive. So if you have questions, definitely ask. Always ask. I know by definition this is right at the beginning of the class, so it's maybe kind of scary. You don't know that I'm a goofball, except that I do have a Sharktopus puppet in my video. So that might give you an indication that I'm not entirely, terrifying. I don't know, maybe having a Sharktopus we didn't get off on the right foot. Now I'm rethinking it. Okay, well, come on back. It's a very friendly Sharktopus. See, smiling, happy eyes. Okay, now, dun dun dun. Now we're gonna be working with negative exponents. And negative exponents basically mean you're in the wrong place. What does that mean? Well, if I've got 3 to the negative 1, or 3 to the negative 1st power, that means I really have 3 to the 1st power in the denominator. So the 3 was in the wrong place. It wanted to be down in the denominator, in the basement. Okay, what about 3 to the negative 2? Well, the 3 to the negative 2 means I've actually got 3 squared in the wrong place. And we know 3 squared is 9, so I've got 1/9. So the difference between, let me find it, right here where we had 3 squared is 9, if it's 3 to the negative 2 or 3 to the negative 2nd, I don't think anyone ever says 3 to the negative squared, but maybe. It just means with that negative in the exponent means that 9 that we got before should be in the denominator. That's all. That's how we write it that way. And again, if you're curious, if you want to know more, you're like, why does this work this way? Definitely ask. Let me tell you something. Teachers, if you haven't figured it out yet, we like to talk. Ask us a question and we will answer it a lot. So please definitely ask. Okay. Oh no, dun dun dun. Okay, I've got my support carnivore nearby. Thank you, Sharktopus, for being supportive, but not too intrusive. Perfect amount of support. I've got a minus in front. I've got a minus in the exponent. Remember, the minus in front didn't actually get invited to the party. I know it looks like it did, but it just hangs out. So the minus is just going to hang out and wait. And now 3 to the negative 2, it's going to be that goes to the party by itself. The minus is hanging out. So I've got the minus out in front, or the negative sign right there. And then I've got 3 to the negative 2, which is, I know from this, 1 over 3 squared, which means it's negative 1/9. Okay, so what if we invite the minus to the party? Well, let's take a look. If we invite the minus to the party, then it's a completely different situation. The negative 3 goes together to the denominator and gets squared. Because remember, the negative exponent right there means that we're in the denominator. Yeah, I'm sorry. My cat and I had a disagreement yesterday. I have thumbs, she has claws. So, you know, I think we achieved detente yesterday, where we agreed that she needs me because I've got thumbs and she can't open the cat food, and she's got claws, so I should perhaps know that when she's suddenly going to be very cranky with me, I should know to just leave the room. She didn't tell me ahead of time, but now I know. Okay, negative 3, the quantity squared, is a positive 9. Do you remember that? Why is that? Well, negative 3, the quantity squared, was negative 3 times negative 3. And again, I get to do the 2 minuses, make a plus. There we go. Woohoo. Okay, y'all ready? 9 squared, 9 times 9. And you're right to be nervous whenever the problems get easier in a math, when we're going through and you're like, wait a minute, that was suddenly too easy. Yes, you should be very suspicious. Yes, you absolutely need to pay attention, because the very next one is a preview of what's coming in 0.4. So I just want to remind you that rational exponents, which is what 0.4 is all about, mean that we're actually in a radical situation. I know, it's radical, dude. In the language of my, California heritage, brief 1980s California heritage, 9 to the 1/2 is the square root of 9. And again, if you don't remember why this is and you're like, what in the world is even happening here, please come and ask me questions or ask the tutors. We can explain it. I'm more focused right now in reviewing and making sure you know how to do it. I'm not going through all of the whys, but I'm happy to do it. I also have tons of videos up. So if you want to see the video from my algebra classes on why this even happens this way, let me know. I'll help you find them. Okay, so 9 to the 1/2 is the square root of 9. Now, normally we would not write the 2 in. I'm making sure that you see the 2's there so you know the relationship. And this is, I said, the square root of 9. Technically, it's the positive or principal square root of 9. In other words, it's the one that is a positive 3. And you may know in the back of your head that 9 has 2 square roots. There's one square root of 9 that is 3, and there's another square root of 9 that is negative 3. When we are looking at 9 to the 1/2, or we're looking at square root of 9 or radical 9, we mean the positive one. Okay, so then what is 27 to the 1/3 power? Well, in the same way, this is going to be the cube root of 27. And that is, again, 3. As you can tell, I really loved 3 when I was writing these problems. Is it possible to do these on a calculator? Absolutely. Am I hoping that you understand these, just in your head without using the calculator? Yes to that as well. And again, if suddenly this is like, what? I don't even know what's going on. Oh my goodness. Don't panic. Don't panic. Talk to me. Let's get you set up with some tutors, or you can talk to me in office hours if you want to be brave. Not that I'm scary, just that a lot of people sometimes feel intimidated. You should not. I'm a big old goofball with my Sharktopus puppet. But I'm happy to explain these. So if this is all just a little rusty, the homework hopefully will give you more practice. There are actually video solutions attached to the homework that you can look at as well. Lots of help available, just ask. Okay, let's go on. Dun dun dun, third page. Oh no. Yes, it turns out we are going to be using variables, actually a lot of them. So we got to review all of this. Now that we reviewed with the numbers or the constants, we're going to be working with the variables. Okay, so it says simplify using only positive exponents. This is a particular type of instruction. Sometimes the homework asks for this, sometimes it doesn't. It will really depend on what the setting is. So as we move through the class, I will try to be very clear. But if it's ever unclear, say, how would you like us to format our answers? Because a lot of problems with math, the answer is you can give one answer in multiple different ways. So if it's not clear, always ask for clarification. I'm always happy to explain that. Okay, so this is an unfortunate little multiplication because I have trouble getting the multiplications to format properly. This means I've got an A and I've got another 4 A's and I'm multiplying them. And I'm just going to rewrite that this is A to the first times A to the fourth, right? A by itself is A to the first. And I'll remind you that when you multiply, you're actually going to, you got it, add the exponents. There's 1 and another 4, so altogether you've got 5 A's, which hopefully feels kind of self-explanatory. I had 1 here, 4 more, altogether I've got 5 multiplied together. Okay, how about this one? Dun, dun, dun. I've got 5 A's multiplied times each other on top and 1 A in the denominator. And again, when I'm dividing, instead of adding, I'm going to subtract. I have the 5 on top minus the 1 on the bottom, which means I have 4. Now, did you have to use this method? No. You could, where's my magic pen of destiny? There we go. You could write out 5 A's and try, that last one is, I swear, it's trying to be a 9. I'm sorry. Sometimes my hand has fun with us. So you write out 5 A's multiplied together. There's 1 A in the denominator. You cancel the 1 A unless your pen is dry. And then you've got A times A times A times A, which is A to the fourth. Woo! Yay! Or A. I know, I'm hilarious. Okay, next up, A to the first over A to the fifth. Now, you've got a couple of possibilities. You are allowed to go ahead and, just like I did up here, you could do 1 minus 5, which is A to the negative fourth, but then it isn't matching the instructions. So what you'd want to do is then rewrite that as 1 over A to the fourth. Put the A where it actually wants to be. Again, a negative exponent means you are somewhere you don't want to be. That's all. Okay. What is the other way to work this out? Well, there are many ways. You could do it this way as well, or you're allowed to move them. So this process was moving them all into the numerator. I could move them all in the denominator. What? So I start with the 5 A's that were there, and I'm going to move the 1 down. That leaves just the 1 up top. And then I get A to the fourth, which is the same answer there, here, like that. Okay, and again, I am hoping that me going through this is jogging your memory. If you're finding this very challenging or you don't remember ever doing this before, please talk to me because this is going to become very important. It'll feel like this is completely unimportant for many chapters, and then all of a sudden it's going to hit right when everything gets really, really complicated in chapter 6. A little bit in chapter 5 too. So you definitely want to review it now. before things get really exciting. Because in chapter 6, you're going to have other stuff you're going to be paying attention to. It's a whole ball of fun. Trust me, you're going to love it. Okay, dun dun dun. This is actually one of my trademark moves. As one student once put it, easy, 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 oh no. I love to give the introductory ones as being fairly straightforward, not necessarily easy, but simple, few parts. And then all of a sudden, wham, here comes the one that is, got all the everything. The first thing that I will usually do with a very complicated problem like this is to go ahead and write the whole thing out again. So that way I have a clean copy and that I can refer back to if I have any questions. And here I can start messing with this so I can cross things out and move things around so that I don't have to worry about being able to read what I've done. Obviously, in a perfect world, you write out your work so that everyone can understand what's happening. But honestly, a lot of times things just get kind of, things get stressful. Sometimes things get a little scratchy. That's okay. So a few things I notice I've got a single X on top and a single X on the bottom. They perfectly match each other. I'm going to cancel them out and I'm going to see what I've got left. And this is my personal style because I have I have dyslexia, and mostly because dyscalculia wasn't a thing that anyone talked about when I was little. But so I know that my problem solving style is that once I make a change, I have to rewrite it because I have a tendency to, move stuff around or misread things. So as simple and as clear as I can make my steps, that'll help my eyes and my brain know what's going on and actually work together properly. So you've got a couple of options. And you may have approached this in a completely different way than I did. But I saw the matching X's. That I thought was a great way to simplify. Next thing, z to the 0th, I'm going to say is 1. Now, you're going to say to me, what if z equals 0? Don't worry about it. Z is not 0 in this case. If z were 0, we'd have a bigger problem that we've got something with 0 in the denominator, which is be a mess anyway. So the fact that this even exists means z is not 0. Don't worry about it. Z to the 0th is 1. We're good. Okay, so I got a 1 down there. So I'm going to rewrite 3 to the negative 2, y to the negative 2 all over 3 times y to the negative 5. Now, I am very tempted to cancel these two 3's. I should not, because this 3 is not actually up here. It really doesn't want to be up here. It's really not there. It wants to be in the denominator. The y that's up here, y to the negative 2, is actually down in the denominator, and the y to the negative 5 is up top. Now, can you work with this with the negatives? Absolutely. A lot of people love to. I'm going to choose a slightly longer version that I think a lot of people prefer, which is I'm going to take a step and move everybody where they want to be. So let me get out some colored pens. Here we go. Okay. So I'm going to start with this 3, which is exactly where it wants to be, so it's not moving. Okay, nice. Next up, I'm going to look at the 3 to the negative 2. The 3 to the negative 2, not happy where it is. So we're going to move it down. And it was 3 to the negative 2. Now it's going to be 3 squared. Down there, right? Once you move it, you change the exponent to a positive. Okay, next up, light blue. This y to the negative 2, not happy. I'm going to move it down here. This y to the negative 2 is going to move down here. It becomes y squared. And this y to the negative 5th, that's not happy down there. I'm going to move it up top and make it a y to the 5th. There we go. So what I did first was I simplified by moving everybody to where they really want to be. Next up, let me figure out what I got. I got y to the 5th up top. Now I've got a 3 times 3 squared. So that's a 3 times 3 squared, which is 9. 3 times 9, that's 27. So it's either 3 cubed or 27 down there. I've got y squared in the denominator. Let me scooch this up and do one more line. Y to the 5th all over 27y squared. Now I look at this and I see, ooh, there are a bunch of y's on top, fewer y's on the bottom. I'm going to bring all the y's together up top. How do I do that? Well, let me walk you through it again. You start with the 5 y's that were already there. And since we're moving someone, whenever you're moving, it has to do with a minus. So if two things are together in the same level, then you're adding exponents. 3 to the 1st times 3 squared is 3 cubed, or 27. When you're moving them top to bottom, you've got a subtraction. Whoever's there comes first, and you subtract whoever's moving. Now this means y squared moved up, so all that I have in the denominator is a 27. And then I've got y cubed all over 27. Now, because for cleanliness, I just haven't boxed everything, because I think boxes sometimes can look a little confusing. However, if you've got a whole whack ton of work, it's a good idea to box your answer, just so that someone looking at it knows where you can kind of navigate it. It helps. This is where I began. This is where I end. Woohoo! You guys, you made it through. Woohoo! Okay, next up, 0.4, we're going to be talking all about, well, more of these guys, radicals and rational exponents. So until then, math on. Woohoo! Sharktopus says hi. Dance party. Woohoo, dance party. Okay. Woohoo, math on.